As the name itself explains, volatile is something that change very frequently. So in case of embedded C, volatile keyword if applied to a variable that tells compiler that that variable should not be optimized. Even optimization is enabled, but that variable will not be optimized by compiler. So sometimes you may have seen issues that a variable is changed from ISR, but it is not updated in the main flow of the code, because during that case it might be the possibility that compiler may have applied some optimization on that variable, and it may give some issues. So to avoid such kind of issues, volatile keyword is applied to a variable. There are three use cases which I listed. It is used with memory mapped peripheral register, because values on those register are updated very frequently. And second one is global variables modified by ISR. And third one is if data is shared between tasks in multi-threaded applications. So let us see a use case. This is a bare metal program which I am running on a target board. So in this example we will see if we don't use the volatile keyword, how the problem is introduced when we enable the optimization. So in this example I have a function app in it which I am calling from main, and this is running in a while loop, and here I have a flag. If it is true, then this while loop is breaking. So if it is true, it get out of here and it go to this line number 15, and this flag I am setting from a timer interrupt at every 2 milliseconds. So here you see first time I don't enable the optimization. My compiler optimization is none, and let me run this program and see what happens. So I'll put a breakpoint here. See, after 2 seconds the program is halted, and it comes to this statement. But if I enable the optimization, then this behavior is not reproduced. I enable the optimization and I keep the high optimization. Now let me run the same program. Let me put a breakpoint here again and then see if it comes after 2 seconds here. You see it do not come here after 2 seconds. Let me see where is my program. It is keep on coming here. Even this variable is set by here in timer interrupt, but it is not coming here. Problem is with when we enable the optimization, this condition is not checked again and again because it is optimized. So here we should use the volatile keyword. Let me run this program again with high optimization. This time it should come here. See, now it is coming here. So that's why we should use optimization if we are updating some variable from ISR and using in our main loop. So this was one of the use cases. Static is one of the storage class in C, and static keywords can be used with a variable or function. If it is used with a variable, it tells that where the variable will be stored and what will be the initial value of that variable and what is the scope and life of that variable. Here you can see that if a variable is defined as a static, it is stored in data segment section of RAM, and if it is not initialized, its value is 0, and its scope will be within a block in which it is defined, and its life will be till end of the program. So even we define a variable in a function that is local to that function, but its life will be till end of the program. One of the use cases of static is it can provide the encapsulation in C. Let us understand with an example. In this example, I have a global variable test_var and I have made it static. It means this variable is not visible to other file. We can have the variable with the same name in other file, and if we want to access this variable from this file, here we can use get and set method. So that's how we can achieve encapsulation using static keyword in C. If you see the map file after compiling this code, you can see that 2 bytes are allocated in data segment section. If you have a static variable that is local to this method, let's say this is the variable var1. So even this variable is defined in this method, but it is not allocated in stack because it is a static variable. It will be allocated in data segment section. So it will be active till end of the program, but its scope will be limited to this method. It means this var1 cannot be accessed outside of this function. Like a static, extern is another storage class in C, and it can be used with variable or functions in C. If it is used with variable, it tells that variable is stored in data segment of the RAM, and if it is not initialized, its value will be 0, and its scope is in multiple files, and its life will be till end of the program. So one of the use case of extern is it can provide access of a variable between multiple files. Let us understand it from an example. In this example, flag is a global variable that is defined in this source file app.c. But if you see that this flag variable is accessed here, even though it is not defined here, but it is accessed another source file. How is that possible? That is possible using extern keyword. Let us see. Here I have added a line extern bool flag. This is telling me that this flag variable is defined in some other source file. That's why to use a global variable that is defined in one file, we have to use this extern keyword. Let's say if I remove this extern bool flag line and I try to build it, it should give me an error that undefined symbol. Here you can see that this flag is undefined in this source file. So that's why we should use an extern keyword if we want to access one global variable from other source file. Constant keyword can be applied to a variable which tells the compiler that variable value should not be changed. Even developer change it by mistake, compiler throws an error. In this example, I have a variable pi and its value is 3.14, and this pi value is used in many calculations. If developer change it by mistake to 3.5, then all the calculation will be changed, and that may lead to some false result. So to avoid that, I use constant keyword with this variable pi. If I try to compile it now, compiler will throw an error message that this is a constant keyword. Interrupt is a signal which is given to the controller. When it is given to the controller, it tells controller that it needs immediate attention. So that time controller halt its work and it shift to interrupt service routine. An interrupt can be generated from hardware and software, and there must be an ISR or interrupt handler for every interrupt. So when an interrupt occurs, the controller runs the interrupt service routine, and there is a table which contains all the memory location which holds the address of ISR routines. That is called vector table. So how it works is, when an interrupt triggered, controller stored the program counter and stack pointer to know where it was before switching to interrupt service routine, and after that it switched to interrupt service routine, and then it does the work and come back to the main flow where it was left. When we use the array in C program, we must know the size of the array. So that is actually known as a compile time memory allocation. But there might be a situation when we want to allocate the memory at runtime. So allocating the memory at runtime is called dynamic memory allocation, and the memory at runtime is allocated from heap region of RAM. And there are two API, malloc and calloc, which are used to allocate the memory at runtime. If we want to free the memory which are allocated from malloc and calloc, we have to use free function, and we can reallocate the memory using realloc function. All these functions are declared in stdlib header file. If we see the malloc syntax, it takes only one argument, that is the block of bytes that has to be allocated. Here you can see that this is the block of bytes that should be allocated this malloc function. If it is allocated successfully, it returns pointer to the first block of memory allocated. If it returns null, it means that memory is not allocated successfully, and this memory is allocated from heap region of the RAM. And the malloc function does not initialize the memory block. It means that whatever the memory is allocated, that will have some garbage values. On the other hand, calloc takes two arguments. First one is the number of block that has to be allocated and the size of each block, and it initializes the memory block to 0. In embedded system, most of the MCU are running using bare metal program. It means there is no operating system running on those MCU. So when there is no operating system, it means there is no scheduler which can manage the scheduling. So that's why we use while loop, so that our program keep on running in this while loop and we can do our task in this while loop. So there might be some interrupt which might be triggering in between, and we do something in this while loop. If we do not have this while loop, then our program will come out of our main, because there is no scheduler in bare metal system. Before coming to this main function, there are some steps which MCU does to reach this main function. So if you see in this example, in most of the embedded system you will see a startup file like this. What it does, when MCU is resetted, it goes to a reset vector. So reset vector is an address which is triggered after the MCU is resetted. That it does these things. It initializes the stack pointer, it set the program counter, and it set the vector table which contains address of different ISR, and then it configured the system clock. After that it comes to main function.